Good afternoon or good evening, whenever you're watching this. Welcome to lesson 63, addition of vectors. You know the majority of the topics covered in this lesson. We are simply now going to be combining vectors polar form, synonymous with each other, in questions that look just like this as we get started. So let's assume that I am going fishing, and I'm starting at the docks, the origin 0, 0, and I go 7.07 at 45 degrees. So as it turns out, that actually ends me up right here, and the vector, or the polar form, if you're looking at it, puts me from the origin right to there. So that's 7.07 at 45 degrees. First quadrant. Great. I fish, I hang out for a little while. Fishing's not great. I want to go elsewhere. Find fishing where it's better. So what I decide to do then is to go 10 at 150 degrees. That 10, let's assume that 7.07 was nautical miles. I'm going 10 nautical miles now. Well, I'm not going back to the origin and then going 10 at 150. Instead, I'm going to be where I was fishing. And now I'm going to go 10 this way, which is about 150 degrees. Now, how do I know that? I know that because if I overlay another graph starting at that exact intersection, then 150 degrees is something about right there, meaning that this distance from this new origin, from where I had been fishing before, to this new point where I'm fishing now, is my final position. So if I get rid of the graph now, that red spot is my final position. I want to know where that is in relation to the origin. And the next example, the example that we're going to do now, going through this entire example, is going to tell us how we get there. Few rules you need to have under your belt before we get started. Number one, you cannot add vectors. I mean, think about what we had just done. At first, I went 7.07 at, now there's no proper add symbol here in terms of the math that we're showing, so I'm using this, but 7.07 at 45 degrees. Then I went 10 at 150 degrees. Did I end up at 17.07 and 190 degrees? Well, 190 degrees puts me in the third quadrant. No, I did not end up in the third quadrant, somewhere down here, 17.07. So you cannot add vectors. Then what you need to know, of course, is how to be able to do a problem like this. And you're able to do this sort of problem if you add rectangular coordinates. So then your steps are definitely going to be convert each vector to its rectangular form, then add those rectangular coordinates, and lastly, you're going to want to put this back into polar form. because I want to know the relationship between where I am and the origin. And again, please let me remind you that polar form and vector form are synonymous. All right, so let's get to the problem then. As a new page comes up and we paste the graph back down, first thing I did was I went 7.07 at 45 degrees and I ended up here. Now, I picked 7.07 purposely because it works out to be really nice numbers here, but I do set up my right triangle, as I always do, on the x-axis. I know that my distance is 7.07 and I need to find theta. Well, in order for me to find r and u, cosine of 45 degrees is going to be equal here to r divided by 7.07. Sine of 45, which is equivalent to cosine of 45. U divided by 7.07. And I came up here with 5r plus 5u. We can confirm that from the graphing calculator. The cosine of 45 degrees is being rounded this very moment, which it shouldn't be and is also in the wrong mode, so we'll change that. We can try that question again. Second entry, 0.707, and multiply that by 7.07, and I get something very, very close to 5. It definitely turned out to be 5 this time if I was rounding, as we've talked about. Of course, the sine of 45 is exactly the same, and so it works out to be perfect there. So that's 5r and 5u. All right, next thing I want to do is I want to be able to convert my second part of the problem. And so if I get rid of this entire graph, and get another graph up here, I am restarting my work because I do each of these individually, and now I'm going with 10 at 150 degrees. 150 puts me out here in the second quadrant. I'm going about 10. I'm not entirely sure where that ends up. Let's just assume it ends me up, somewhere over here. I'm going to create my right triangle again, looking for RU. Of course, I do need theta this time. Theta at 150 degrees, so this is 150 degrees right there. Theta is my angle underneath. That's 180 minus 150, which gives me an angle of 30. So I'm looking for R here, U here. R, of course, is going to be negative. And I'm doing the exact same type of trigonometry, just with a different angle here. So it's going to be the cosine of 30 degrees is going to be equal here to R divided by 10. We're going to have the sine of 30 degrees equal to U divided by 10. When I type these into my calculator here, I'll get cosine of 30 is equal to that. Multiply it by 10, I get 8.66R, except that was a negative, so I'll write that down as a negative value. If I do the sine of 30, well, that actually turns out to be 0.5, and multiply that by 10. Of course, I'm picking numbers that I really wanted to use because they are numbers that are going to be coming up briefly in our lessons, so I wanted to cover those. And now I end up here with negative 8.66 r plus 10 u. Now, if I add these two vectors, or rather add the two rectangular pieces of the coordinate, and I'm going to rewrite this over here. Negative 8.66 r plus 10 plus 5u. I had made a mistake there, so I apologize. I can go correct that momentarily. So that was a 5. As we saw in the calculator, bring that back up. That's 5. I wrote 10. I actually ended up overall back at, oh, well, this is added together. These two become negative 3.66 r plus 10 u. Negative 3.66 r plus 10 u. Let's go back to that first picture that we had up here. Negative 3.66 r about in here. 10u up, and that looks to be about where I ended up. That's great. This is working out perfectly. The only thing I have left to do is actually write this in proper form. So that means writing this back in polar form. So I am going to bring this point right back. Negative 3.66 r plus 10u ends me up there. I'm looking for distance and theta. My distance d is there. My theta angle is in here. I find distance by using Pythagorean theorem. So that looks like 3.66 squared plus 10 squared equals d squared. Doing that on my calculator, I came up with d is equal to 10.65. So the distance I traveled was overall was about 10.65 nautical miles. In order to find the angle theta in here, this is tangent of theta. Now I don't have the symbol theta, or potentially I do. Let's look for that one in here. I do have theta, sorry. Tangent of theta is equal to, and then I've got opposite. Opposite here is 10 divided by 3.66. I do the inverse tangent of my calculator, and theta I ended up with. So second tangent, opposite over adjacent. (69.9 degrees). 69.9 degrees. And that leaves me just writing my answer in proper form now. The answer in proper form will be my overall distance, 10.65 at, again, you should be trying to use the symbol. Now it's not 69.9 degrees because I am looking for this angle there. Theta was 69.9, so I need to subtract that from 180 degrees. So 180 minus 69.9 puts me at 110. 110.1 degrees.